Okay, so get this right. We're talking about a fuel source, and it's 20 million times stronger than hydrogen.
Yeah, you heard that right.
20 million times.
Oh.
And this isn't like, Star Trek stuff. This is actually based on real theoretical physics. We're diving into the wild world of black holes and Hawking radiation.
I'll use it for that.
Now, Hawking radiation, I know it might sound kind of intimidating, but we're going to break it down
We are.
in a way that makes sense.
Absolutely. It all starts with Stephen Hawking.
Yeah.
And, this is his groundbreaking work on black holes.
Right.
And, for the longest time, people thought black holes were these cosmic vacuum cleaners, right?
Right.
Points of no return, gravity so strong, nothing can escape, not even the light.
Yeah, the ultimate abyss, right?
Exactly. But Stephen Hawking, he proposed something incredible. What if, right, black holes, what if they weren't completely black after all?
Okay, so how do you go from a black hole to something that radiates energy?
Okay, so picture this. At the very edge of a black hole, this is called the event horizon, right?
Right.
You have all these particles just, popping in and out of existence.
Okay.
It's kind of wild, right? These are particle pairs. Think of them as like these tiny fluctuations, and it's in the fabric of space-time.
Okay.
So now imagine, right? One particle from a pair, it gets sucked into the black hole,
Okay.
but the other one, it escapes outwards.
Well, okay.
And that escaping particle, that's Hawking radiation.
So it's kind of like a cosmic game of keep away, right?
Yeah, exactly.
With incredibly high stakes, obviously.
Exactly. One particle gets trapped forever, the other one gets flung out into the universe.
Right.
And here's the thing. That flung out particle, it carries energy with it.
Okay.
Energy that originally came from the black hole.
Wow.
And this is revolutionary because it means black holes, they're not eternal. They actually lose mass and energy
Wow.
over time through this radiation.
Okay, so black holes are leaking energy constantly.
Right.
But how do we even begin to harness that?
That's the million-dollar question.
Right.
It all comes down to, understanding this extreme environment, right?
Right.
Around a black hole. I mean, think about the energy sources that we use right now, right?
Right.
Like hydrogen fusion. It kind of pales in comparison, right?
Yeah.
To the forces at play near a black hole.
So we're talking about not just splitting atoms, but we're talking about the fundamental forces of the universe here.
Precisely. The theoretical energy density of this concept, it's mind-boggling.
Yeah.
We're talking about a scenario where just a small amount of this fuel, it could power entire cities for centuries.
Really?
Yeah.
So we've gone from black holes being these terrifying voids to potential batteries of unimaginable power.
It's true.
Okay. That's a lot to wrap my head around.
It is.
Right.
It is. And we're just scratching the surface. But before we get ahead of ourselves, right, and start planning, these interstellar voyages, we need to acknowledge the reality of this situation. And that reality is this. Harnessing this kind of power, it's riddled with challenges.
Yeah, I have a feeling we won't be trading in our, gas-powered cars for black hole-powered vehicles anytime.
Probably not.
Probably not.
But that doesn't mean, right, that the exploration of this concept it isn't important.
Right.
Because it's this pursuit of the seemingly impossible that leads to, the most profound breakthroughs sometimes.
Okay, so we've established that tapping into the energy of a black hole, it presents, a few minor hurdles.
Right.
A few.
A few.
But let's just say for a moment that we could overcome these challenges.
Okay.
What does that world even look like?
It's a great question.
What does it mean to have access to that kind of energy?
Well, I mean, for starters, right, it would completely revolutionize how we think about energy, right?
Mhm.
I mean, we're so used to thinking about energy in terms of scarcity, right?
Yeah.
Fossil fuels, solar power, even nuclear energy. I mean, they all have their limitations.
Right.
But this is different. This is about accessing a source of energy, and it's so vast.
Right.
It's so potent that the idea of scarcity, it just becomes irrelevant.
Okay, so are we talking energy bills are a thing of the past?
Possibly.
We power our entire planet on a sugar cube size amount of black hole fuel.
Again, it sounds crazy, but the theoretical potential is there, right?
Right.
Think about it. Imagine, if you will, a world where, energy-intensive industries, they don't contribute to climate change anymore.
Right.
Developing nations, they have access to the same energy resources as the developed world. I mean, this is the type of technology that could level the playing field and usher in an era of, unprecedented global prosperity.
That's a powerful thought. A future where energy, it isn't a source of conflict, but a tool for progress, and it's available to everyone.
Exactly.
But with that much power, I have to imagine there'd be risks, right?
Of course.
I mean, we're talking about harnessing forces that make, like, nuclear weapons, they look like firecrackers.
Yeah, no, you're absolutely right to raise that concern.
Right.
Because the potential benefits of this technology are enormous, right?
Yeah.
But the risks, they're right there too. I mean, if we were to somehow miscalculate, right, or mishandle this kind of energy, the consequences could be catastrophic, right?
So what kind of risks are we talking about here? What could potentially, like, go wrong?
Well, I mean, think about it, right? We're
Yeah.
talking about manipulating forces that they shape the fabric of space-time itself.
Right.
Even a slight miscalculation, a tiny error, right, in our understanding, it could have these unforeseen and potentially devastating consequences.
Right.
I mean, we could create a black hole. We could disrupt the balance of forces that hold our universe together. I mean, we could unleash energy, on a scale that could wipe out entire star systems.
Okay. Now that's terrifying. So it seems like with this kind of power, there's a whole other level of responsibility, right, that comes with it.
Yeah, absolutely. This isn't just about figuring out the science, right?
Right.
This is about grappling with the ethical implications, right?
Yeah.
Right.
The potential consequences and just the sheer responsibility of wielding that kind of power.
Right.
We need international cooperation. We need stringent safety protocols.
Yeah.
And we need a deep, deep understanding of these forces that we're dealing with.
So it's not just about building a bigger, better battery. It's about navigating a future where humanity has access to power beyond, our wildest dreams.
Absolutely. And while this technology might be centuries away, right, the ethical and philosophical questions that it raises, they're relevant right now.
Right.
It forces us to confront our own limitations, you know, our capacity for both creation and destruction, right?
Right.
And ultimately what it means to be human in a universe full of such awe-inspiring power.
Okay, so we've talked about, the potential of black hole energy.
Right. And those challenges, those responsibilities that come with it.
Right.
But, I know what our listeners are really thinking, right?
Right.
When could all of this happen?
Yeah.
Are we talking about like a future that's centuries away?
Well,
Or could this be closer than we think?
the article we're discussing, it suggests, centuries.
That's centuries.
Before we have even a remote chance
Yeah.
of harnessing this energy. And even then, it's highly, highly speculative.
Okay. I was hoping for something a little sooner, but I guess that's,
Right.
that's why they call it theoretical physics.
Exactly. But here's the thing about scientific progress.
Yeah.
Right.
Okay.
It doesn't always move, in this straight line.
Right.
What seems impossible today could be, commonplace tomorrow, right?
Right.
Think about the advancements that we've seen just in the last, few decades.
Right.
The internet, smartphones, gene editing.
Right.
I mean, these were all once considered, science fiction.
Yeah, things are changing faster than ever.
They are.
So even though, we might not be building black hole power plants anytime soon, the research itself, like the pursuit of this knowledge, it's still incredibly valuable.
Absolutely, because this kind of exploration, it pushes the boundaries of our understanding. It sparks new discoveries.
Right.
It lays the groundwork,
Right.
For future breakthroughs. Who knows?
Yeah.
What other mysteries will unlock along the way, right?
Yeah. It's like that saying, right? It's about the journey, not the destination.
Exactly.
Right.
And what a journey it is. I mean,
Yeah.
just imagine, right? The quest to understand and potentially harness the power of a black hole.
Right.
I mean, it's a testament to human ingenuity, right?
Right.
Our boundless curiosity and our relentless desire to, explore the unknown.
So even though we might not be booking our, tickets to a black hole powered future just yet,
Right.
just asking these questions,
Yeah.
exploring these possibilities,
Yeah.
that's what, propels us forward.
It does. And who knows, maybe one of you listening right now will be the one, right, to make that breakthrough,
Yeah.
to crack the code of black hole energy and change the world as we know it.
And when that happens, you better believe we'll be here to cover it. This has been The Deep Dive, reminding you to never stop questioning, never stop exploring, and to never underestimate the power of a curious mind. Until next time.